Welcome back. This is our video solution to problem 2b from Superquiz 2. And we're finding another antiderivative. In this case, we're going to find an antiderivative for the function 5s squared plus 10 divided by the product of s plus 2 with s squared minus 2s plus 2. All right, well, if if you ever saw a fraction that looked more like a partial fraction problem, right, I'd like to see it. So we're going to want to break this up. And there's a linear piece here. That's easy enough. So let's see. In order to get the numerator, we know it's going to be a constant, and we can find it by ignoring this s plus 2. And what's a root? -2. We just evaluate this function without the s plus 2 at s equals -2. So at s equals -2, let's see, -2 squared is 4. 4 times 5 is 20, plus 10 is 30. Divided by, okay, again, -2 squared is 4, minus 2 times -2. Okay, 2 times -2 is -4, so 4 minus -4 is 8, plus 2 is 10. Cool, so we have 30 divided by 10, which is equal to 3. Great, well, we're not done, of course. Now we need, well, this is the hard part, right? So here we have a quadratic, and the first thing, of course, is we should make sure we can't factor it. And we can always test if you can factor it, right? So I look at s squared minus 2s plus 2, oops, minus 2s plus 2, and I'm going to take this coefficient, this minus 2, and I'll square it, and I'll subtract 4 times the leading coefficient, which is 1, times the constant coefficient, which is 2. And this is 4 minus 8, which is definitely negative, which tells you this is an irreducible quadratic. So we're not going to be able to factor it over the reals. All right, so we're just going to have what it is. Now, one thing that might be useful later on, because we're going to be integrating this, is to complete the square. So I divide by this middle coefficient, I get s minus 1 squared. Let's see, that would give me a plus 1, but I want a plus 2, so I'm going to need a plus 1. Okay, that's not going to help us do the partial fractions, but I usually just like to take care of this before I get a lot of clutter, right? Because I know I'm going to want to use this ultimately. Okay, in the numerator, I'm going to need a linear function, right? Whenever you have an irreducible quadratic, you have to use a linear function, not just a constant function in the numerator. All right, well, let's continue on, right? We're going to clear denominators, so I'm going to multiply through by this entire denominator. And when I do that, I'm going to end up with 5s squared plus 10 is equal to, okay, so this first term, I have a 3. Clearing the denominators will kill the s plus 2, but I'll have this irreducible quadratic. So s squared minus 2s plus 2. And then the other piece, I'm going to have as plus b, and that gets multiplied through by this denominator. Okay, the quadratic factors, and I just have to multiply by s plus 2. All right, now all I need is the a and the b. And my favorite thing to do in these situations, right, for the a, look at the highest degree terms. So in this case, it's squared terms. We have 5s squareds on the left. And on the right, I have 3s squareds and as squareds, right? As times s. Okay, so a has to be 2. Great. And then to get the b, I like to use the constants. So for my constants, okay, I have 10 on the left. On the right, I have 3 times 2 is 6, and b times 2 is 2b. So I need a number that when I double it and add 6, I get 10. Okay, so b has to also equal 2. Fantastic. So I have 2s plus 2 here. Okay, so this integration problem, we can rewrite it then. This is an integral now of 3 over s plus 2 ds. I'm going to break this up. Plus an integral of 2s plus 2 over s squared minus 2s plus 2 ds. And you say, oh, didn't you say you're going to use this? Well, it's coming. Now, let me make a little room here, clean this out of the way a little bit. Okay, so here's the thing. My first thought when I see this is I would like to use substitution. I see a function, and I see it, well, almost its derivative. The derivative of s squared minus 2s plus 2 is 2s minus 2. Oh, it's so close. I have 2s plus 2. All right, so what I'm going to do is cheat. All right, I'm going to cheat by taking this plus 2 and making it into a minus 2. You think anybody saw? All right, well, in math, you can only cheat for a little bit. You can't cheat for too long. So I really am supposed to have 2s plus 2, and now it says 2s minus 2. I can fix it by adding 4. All right, now I'll have 2s minus 2 plus 4, that's the same as 2s plus 2. And I'll put some parentheses. And now what I'm going to do is break this up again into two different integrals. Okay, so this piece here will be the integral of 2s minus 2 over s squared minus 2s plus 2. And then this remaining bit, 4 over s squared minus 2s plus 2. All right. And the first two I know how to handle now. All right. So what do we get? This first one, this is just 3 times the natural log of s plus 2. This second one, okay, this is that situation. I have a function in the denominator. I have its derivative in the numerator. So in my mind, I could do a u substitution. And my du is, okay, it's just going to be this numerator times ds. So I'm really just integrating 1 over u, which is ln of the absolute value of u. And there's my u. So ln of the absolute value of s squared minus 2s plus 2. So the only thing I have left is this nasty one here, and that's where this completing the square business is going to make my life better. I'll rewrite this now as s minus 1 squared plus 1. And do recall, so let's just do a little work on the side here, right? If you integrate 1 over x squared plus 1, this is arctangent of x. And that's essentially what I have here. Okay, I've got some extra junk. There's a 4, but I can pull that out. And then there's a little shift here, right? But this is just a little composition with a linear function, right? That's not going to hurt me. So what I can do here is get 4 times the arctangent, well, not of s, but of s minus 1. All right? And because the coefficient in front of s is just 1, I don't even have to correct. If you don't believe it, just take the derivative of this. You'll get 1 over s minus 1 squared plus 1 times the derivative of s minus 1. But the derivative of s minus 1 is just 1, so you don't get any extra junk there. So there we go. We have found our antiderivative. It wasn't easy, but we did it. Good job, everybody.